minutes. I'm going to shut off my camera, Philip, but I'll still be here in voice. There we go. You can still hear me, Philip?
Yes, I can.
Excellent. So we're just going to, guys, everybody who's popping in, if you just want to give us just about 3 more minutes, we're going to get things rolling here. And Philip's going to go through NetFoundry's Hackathon Challenge and their technology. And Philip, are you doing a screen share of your presentation?
I am going to do a screen share, but you've got the slides as well for backup if needed.
Right. So why don't you go ahead and hit the screen on the right-hand side of your viewer, click on that, and then start the screen. Just let's get the screen share going.
Okay, one moment.
Looks like it's working.
Cool.
All right. Terrific. So what I'm going to do, Philip, when I'm finished my intro, I'm just going to switch back to your screen share, and you can see that in the upper left-hand corner. You see camera, slides, and screen, so we can look at the different feeds that are coming in. So I'm just going to leave it here for just 1 more minute. All right. I'm going to do some housekeeping here, and then I'm going to hand it off to Philip to do the hackathon itself. I'm Patrick Gallagher, and I'd like to welcome you to the Developer Week Europe Hackathon webinar presented by one of our hackathon sponsors, NetFoundry. Before we get started with the speaker introductions, I'd like to remind our attendees that there is a live chat available, and Q&A is available during the session. And you can also put your questions right into the chat box, to put any questions you have there right into the chat function so that Philip can answer those questions for you. We're also recording this session so that this recording will be made available to anybody who's attending the webinar right now, and then anybody else who registered for it within the next 12 hours. So that will be available for you to review, as well as any teammates that you're working with as it relates to the challenges. So without further ado, I'm going to introduce our presenter today. It's Philip Griffiths, NetFoundry's Head of Business Development. Philip is first going to review NetFoundry's technology and then their Hackathon Challenge. So without further delay, please give your undivided attention to Philip. Philip, go ahead.
Hey, thanks everyone. So yeah, before we look at the challenge that we've set out, we're going to be talking about what OpenZT and NetFoundry are, because it really sets the stage to understand the powerful implications of the hackathon and how that can be built and deliver the scope. So we'll start with a little bit of background of current network security. When you look at networks, we're basically looking to connect applications and resources so they can communicate together, whether it's me using my laptop to be on this call or whatever use case I have. And traditionally, we tried to protect the network because networks are inherently insecure by design. They're designed to share packets by building walls and moats, firewalls, and that was kind of good enough for the initial period of the internet, but fundamentally it didn't provide us the security we needed. And therefore, we started looking at, well, how do we secure our connections? How do we make it that we can improve how data is being sent? And we thought, well, we'll put TLS everywhere. We'll start encrypting our data. And this very much came from about just over 10 years ago of things like Let's Encrypt and HTTPS Everywhere being made free and easy, because fundamentally, if you're going to secure something, you have to make it free and easy. And these technologies enabled browsers to embed secure connectivity into the browser, so that we were able to move to doing things like internet banking. But it doesn't solve all of our problems. And even if it could solve all our problems, it's not even used in all applications. So let's have a look at one use case, an horizontal movement. A malicious actor is on a network and he is able to move across that, let's call it local area network, and infect other devices. This is quite literally what ransomware is trying to do every single day, pivot from one device to another. They're using Let's Encrypt, TLS, HTTPS for their connections, but fundamentally that is only data in motion security, and we need to stop this. So this setup that we have today is basically how VPNs work. Any single time someone says to me, hey, you need a VPN, it's like, okay, better than nothing, but fundamentally you are not providing the security to stop lateral movement. So then we start saying, well, okay, let's do some segmentation. Let's make it so that people on a LAN environment can't just infect anything else on the environment. And that means we have to backhaul all our traffic to some inspection point where they're able to stop these things from taking place. But then what about if you're able to hop across devices? You're able to circumvent the inspection point. Our segmentation does not completely solve our problem. So then we have the advent of zero trust. Zero trust is now a massively overused term. Everyone uses it. Many use it incorrectly. But it comes from the early noughties as a way to protect our applications as we moved into mobile and cloud. And the premise is basically, don't trust the network at a simplistic level. There's various different levels of zero trust, but fundamentally, never trust, always verify. Now, if we start to look to implement that across our setup that we previously had, effectively what we're looking to do is use strong identity in the endpoints. And again, different people talk about zero trust in different ways. I could share many blogs with you in terms of how some people talk about it and how we talk about it. But in our reality, we say everything needs strong identity. You should not be trusting IP addresses. You should not be trusting the network. You need to use strong identity embedded in applications and devices to have a way to identify who people are. Now, bootstrapping trust is incredibly hard, but we have done lots of work to make it incredibly simple. If you really want to geek out, we have a lovely 5-part blog series which talks about bootstrapping trust, written by Andrew Martinez, one of our advanced development team. And we've done a lot of stuff to make it as easy as possible to generate strong identity, X509 certificates, and to be able to associate them within a network overlay. Now, once we have that strong identity, it's really the foundation of everything, because it enables us to start setting rules and saying who should be able to communicate to what based upon that strong identity. It's almost like giving every single application, every single resource its own little private network based upon that strong identity, so that everything has to be secure, or everything is secure by default. Packets cannot flow across the overlay network unless you've explicitly authenticated and authorized based upon that strong identity beforehand. Now, then we have the malicious actor moving devices and trying to, again, propagate across the network. So this is where we start setting up least privilege, the point of being secure by default. Packets cannot flow unless you've explicitly authenticated and authorized before connectivity. And that enables us to move into what we're really looking to do, which is application embedded zero trust. Within this concept, what is an overlay network? Well, it is a control plane and a data plane which enables us to connect source and destination. We're using a software-defined network architecture, so it separates out the control plane from the data plane because you don't want a single point of failure. This enables us to embed identity into everything and ensure all connections are being done on the basis of that embedded identity, so mutual TLS. everything is secure in terms of how it communicates both on the control plane and the data plane. Now we're able to extend out to the edge, source and destination, client server, server server, machine server, client machine, whatever things we're looking to communicate, we can now enroll them and bootstrap them into the overlay using that embedded identity, and now start saying, hey, I want packets to flow from my laptop and send a asynchronous message to a Mattermost application, which is like an open source version of Slack. We use it inside NetFoundry. But ours is dark. It is unaddressable on the internet because we use ZT in order to access those resources. Now, when we talk about zero trust, there are 3 different ways in which we can do zero trust. We can do the standard that Gartner defines, zero trust network access. And this effectively says, I have zero trust of the internet. Now, again, there are some vendors that say they are ZTNA and they do trust the internet because they're exposed, they have public IPs. But in our world, you only have outbound connections. So malicious actors, the 4.6 billion people or whatever, cannot subject you to attack, be it DDoS, port scanning, brute force, CV exploit, 0 days, because you have zero trust of the internet. There is no inbound ports. There is no a way for them to get in. We then have the ability, though, to go further. Zero trust host access. I have zero trust of the internet, but I also have zero trust of the local network. And therefore, I can provide host to host private connectivity. But we don't even stop there. We also have the ability to deliver zero trust application access, the ability to put our private identity driven network into the application stack itself. Now I have zero trust of all networks, the internet, the local network, and even the host network. This is the logical conclusion of zero trust. One quick caveat, you can mix and match these models. Maybe you have zero trust host access on client side and you have zero trust application access on server side. Or maybe you're using ZTNA on server side and you're using ZTHA or ZTAA on client side. Well, whatever, it really doesn't matter. You're able to do anything within our model. I've already explained all of those. What are other benefits of application embedded zero trust? Well, it enables us to cram our software development kits into your application with strong embedded identity so that we're putting that zero trust directly inside the application. Now, that has a very profound effect because it effectively means each application has its own little virtual private network. And that embedded network enables SCP, for example, on the purple, to only communicate to SCP, and FTP only to communicate to FTP. They are being, as it goes over the network, we're turning it blue because it's got one, or potentially if you're going from device to device, one tunnel, but within there, there's then multiple tunnels which are encapsulated. But effectively, we're given a private network to each of those applications so that the data packets can only traverse to the other end of the source to destination according to its own embedded network. SQL to SQL, FTP to FTP. What is impossible is for a malicious actor to try and compromise FTP from SCP. This is not possible because you cannot be able to orchestrate that type of attack. So what is OpenZT? OpenZT gives us the ability to put zero trust inside our applications, programmable networking inside our applications, and it has a bunch of superpowers. In case you're wondering who is this guy, this is obviously Batman. But this is Ziggy Batman. Ziggy is our mascot for OpenZT. Every open source project needs a mascot, so ours is a piece of pasta, because ZT is both delicious Italian pasta. It's basically a long one with a hole inside, almost like the opposite of spaghetti. Almost you could put spaghetti through it. But ZT is also modern programmable private networking. There are many superpowers you get for your application when you use OpenZT. We use this analogy of the Beast versus Mad Max. If you're not aware, the Beast is the presidential limousine, and it is secure by default. It has bulletproof windows. It has bomb-proof exterior. It has run flat tires. It has a bunch of different things that make it almost impossible to intercept and kill a president. But you wouldn't guess that because it just looks like a car. On the other hand, in Mad Max, this clearly looks like someone working from home and bolting on some exterior defenses to their vehicle to try and make it stronger. But we can see it. We know how to exploit it. We know how to target it in order to defeat it. This is the power of OpenZT. Users don't even know that they're part of a private network. My bank could have OpenZT embedded into my banking application. I'd have no idea. I just use the banking application and I'm connecting to APIs which are private and unaddressable on the internet. It is a transparent experience. It is an incredibly secure experience. But there are other superpowers. Addressability. In standard application world, if I want to address a service, I have to give my IP address and say, I want to talk to this DNS name on this IP address. When you use OpenZT, you get unique addressability. I can send a message from Clint or Philip to Jenkins because the name is whatever I want to call it. You could define a service as 1.1.1.1, and that packet is not going to go to Cloudflare. That packet is going to go to wherever you define the service to be on the other end, because we can call things whatever we want to call them. It also enables us to do zero trust, not just at client side, but also at server side, and have no holes or listening ports at all, which means malicious actors cannot get in and exploit our applications. This is a view of a Java application, maybe running on Spring Boot, and uses log4j. Well, has it been patched? Is it exploitable via log4shell? Is it exploitable via Spring for boot? Spring for shell? Don't know. But fundamentally, if you're exposed to the internet and a CVE or a 0-day comes along, people are going to be probing your application and trying to hack it. Malicious actor was able to do it, and now our applications are compromised. I've literally spoken to an organization who spent $1 million during December trying to find and patch anything that was Java-based so that they wouldn't be exploited. A lot of money. And that was on top of their otherwise big budget that they spend on IT. That was all additional of paying contractors and overtime and holiday pay, Christmas pay, etc., in order to fix the problem. If we make our application have its own private network and close all inbound ports, malicious actors can't do that attack anymore. They can try, but they're not going to get anywhere because they can't get to the application in the first place. The only people that can access our Java application running on Spring Boot are the known and explicitly trusted endpoints which you have enrolled into the overlay network via bootstrapping of trust with an OpenZT endpoint. No one else can access it. It's private. We have recently Zetified Spring, one line of code, you can put it in a Spring application. We actually had a piece with Java Magazine where we talk about making services dark. This actually was before Spring for Shell came along, fortuitous timing. And that was a 9.8. Log4Shell was obviously a 10. So we want to be able to stop those exploits. We want to switch from, instead of, oh my God, there's a 0-day, I need to figure out what's compromised and to patch it ASAP, to, oh, there's another 0-day, fine. I can patch it, but I'll patch it at my leisure because 4.6 billion people cannot instantly try to exploit it because it's exposed to the network. That's not the only thing, though. Another superpower is the ability for OpenZT to be able to access services anywhere. There's no concept of client server within OpenZT. You're able to have a service on a desktop and to be able to access it as if it was a server. If I gave you access to a OpenZT network, you could get access to my device. I could set it up so you could access service. We're just working on a blog about how one of our engineering resources uses OpenZT to manage his IoT network when he's not at home. He doesn't expose it to the internet, but he's able to access it from his endpoints because he's able to access them from anywhere, because OpenZT can handle any use case. This also enables us to do zero trust for what for other vendors is traditionally hard topics. VoIP, yeah, we can handle it. SSH, no problem. We can do any use case. We also use embedded end-to-end encryption using Libsodium, which is Chashar Poly 1305, I believe off the top of my head. That enables us to ensure our application is incredibly secure by design. It has embedded end-to-end encryption from the application over the network to the other side of the application. It is effectively AES-256 equivalent while being much lighter weight, so that it doesn't require as much crypto to be able to process it. So we get better performance and reliability while having high security. And this is on by default. Yes, you can turn off the end-to-end encryption and just have link encryption of mutual TLS between every single hop. But fundamentally, this is in there by design because most people want it. Yeah, I was correct. Another superpower? No inferences allowed. If I put a packet capture on the Wi-Fi network that I'm currently on, I would be able to say, hey, Philip's doing a HTTPS connection for the name of this application, which I forget the name, which we're running this session on. Maybe you can then intercept my DNS on 53. Maybe you can see that I'm doing a access to MySQL on 3306 and be able to infer, oh, Philip is a developer, or Philip is a database administrator, or Philip is this type of person because he's accessing these types of ports and protocols. Not with OpenZT. With OpenZT, that little blue tunnel that we were showing earlier, that's on 443. So everything looks like it's 443 rather than what it actually is. It pops out at the other end on whatever port it needs to for the application to natively communicate, but over the overlay, it all looks like 443. What it's also doing is OpenZT is encrypting data, or the metadata as well. So you also don't know where data packets are coming from or going to if you intercept them. The only thing you can see is what is the next hop on the underlying IP. So everything, that little blue tunnel, it all looks like 443. OpenZT also makes your life easier. Rather than having to define and build your application to do a WebSocket to the local host on a port which you may or may not know, all you have to do is associate OpenZT to your code with its libraries and then say, talk to ZT. If instead of building, when you're going to build a asynchronous server socket in Java, this is an example of, you're going to build to the ZT SDK and everything else gets handled from there. This removes not just the complexity of bolting on VPNs and ACLs and MPLS and the private APNs and complex firewall rules, but it also makes it simpler to actually enable our application to communicate. The only thing you need is outbound internet anywhere. Cloud, edge, IoT, doesn't matter. You just need outbound internet. No ports, no IPs. You don't need to know them. So we have our Zetifications. We have a bunch of SDKs which can be compiled into many different apps, whether it's Java, Golang, Node, etc. But we also have what we call Zetifications. These are ones we've built ourselves. Ziti Kitchen, with Ziggy being a chef, of course. So we've done SSH. We've taken an SSH client and we've jammed OpenZT into it so that you don't need port 22 open, but you also don't need a client on your device. That enables us to protect our application and to make it incredibly simple because it's effectively clientless. SCP, done the same thing. Now we're able to do it in a clientless manner. Same thing with Mattermost. I mentioned it earlier. We have made our Mattermost dark and we've created what we call browser. Our system can inject a JavaScript SDK and identity to run in your browser so that you don't have to load a client onto your device. We can inject zero trust into your system. GitHub and GitLab webhooks. When we push code to our repository in GitHub, we get notifications into Mattermost. But Philip, isn't your Mattermost server dark and unaddressable on the internet? How's it possible? Because GitHub is on a public IP. Well, we built the zero trust webhook so that we can send messages from our GitHub tenancy to a private unaddressable Mattermost server. Here we go. Here's some examples of messages that are coming through from our GitHub robot. JDBC. We took the driver to access Postgres, MySQL, etc., and we zetified it so that you can have for example, a WebLogic server talking to a database, or you can have a database administrator talking to the database. No inbound ports, no VPNs, no complex configuration or code changes. You're just using our zetified jar file. This enables you to effectively just change the jar file, and then you put Z. You reference that rather than your traditional JDBC, and it all works. Exactly. As an example of the change from one to the other. Very, very simple. We've zetified kubectl. You'll notice we put Zs into everything. That's our little thing. And that enables us to enable anyone to have a private Kubernetes API and to just use kubectl rather than kubectl. That enables us to have everything private, but to do it in a clientless manner. How wonderful. Helm. We've just done the same thing to Helm, and we've zetified it. And the reason we did that is for our blog, which we're very close to releasing, for Prometheus. Now you can deploy a dark Prometheus monitoring system anywhere you want, and you can scrape all of the data. You don't have to pull it from the system, or you don't have to push it out through a firewall. You can pull it because you're able to get access to anything without that system being addressable on the public internet. It enables us to have a highly automated and highly secure Prometheus anywhere, or Thanos. Thanos is like the distributed mega Prometheus. Journey. What's this, Philip? This is the longest path in the world across landmass. The point is, Zero Trust is a journey. We would love it if every single application being built today was using an OpenZT SDK, because it would solve loads of problems for the world. But the world's not that simple. So we have built a bunch of tunneling applications which enable us to apply ZT to non-SDK, non-application aware scenarios. Every tunneling application is basically an encapsulation of one of our SDKs running on the popular operating system. So you can apply it to Linux or Kubernetes or Mac or whatever. Another superpower: completely private DNS. No way to be able to see what's happening, because OpenZT is basically locally resolving and intercepting anything, but you can also name anything you want. So, the little joke, you could have a service called Boaty McBoatface, and it will intercept, and it could be taking me to my Mattermost or whatever service I want to intercept. And no one can access it. No one can reach my private DNS. So, the journey continues. What are we doing today? We are talking about how the Biden administration wants us all to put zero trust everywhere, and therefore, named 11 times by Biden, therefore, how can we easily put zero trust into all of our applications? Well, we can use OpenZT. And we have our landing page where we're able to very easily spin up a OpenZT network to deploy it on Docker, or to host it yourself, or host it locally. Pick your SDK, but fundamentally apply it to the hackathon. We have two hackathons. One is build an application using OpenZT, and the other is to deploy a NetFoundry zero trust network, and then to tweet about it, Twitter about it, LinkedIn about it, blog about it, whatever. The second one has, I think it's $100 prizes in swag for 10 people. And it's very simple, particularly because you don't even have to deploy an OpenZT network. You can deploy it to the NetFoundry one. The first one has a much bigger prize. I think it's a $2,000 off the top of my head, but again, we can share the details afterwards, or it's in the DeveloperWeek pages. But effectively, it's to build an application and to embed OpenZT into it in order to have that application and to make it so it's non-addressable on the public internet. Spoken to a few people so far. One person is looking at potentially developing a dark banking application. Another person is looking at doing some sort of storage application. Another person is looking at doing potentially like a JavaScript application, but making it private. This is where it becomes interesting to effectively look at how can I build an application which could be a commercial idea and to be able to embed OpenZT into it. So again, we'll share this information afterwards, but here's some other interesting resources, links to how OpenZT works architecturally. We have the ZTTV, which has a load of videos where we've Zetified things, Nats, Prometheus. We just had something on Spiffy Spire using that as a CA. We have our community where we have people asking questions around what they're doing in the hackathon and how to build use cases for OpenZT. We have a few videos which we'll be sharing around how people have Zetified other applications, whether it's a Golang application or a Java application or other things. But also, if you want to take the easy button, you can use the NetFoundry platform. NetFoundry is NetFoundry is the creator and leading contributor to OpenZT because OpenZT is open source. So NetFoundry is effectively an open core company. We've built the NetFoundry platform, which is effectively SaaS of OpenZT. We have freemium tiers, which are free forever. So you can just spin up a NetFoundry network and focus on Zetifying the edge, the applications. We have no preference as to whether you stand it up yourself or whether you use the NetFoundry platform. The key is picking the awesome use cases, which are commercially viable and could be used to go to market according to the rules of the hackathon with DeveloperWeek, while simultaneously embedding one of the OpenZT SDKs into either source or destination, or possibly both. It could be SDK embedded on both sides. It could be SDK on the server side, and I'm using tunnelers on the client side because it's easier. We have no preference for that. We're interested to see how you guys innovate, because ultimately it's all about being able to innovate faster. That is the end of our presentation.
Philip, thank you for that. Was a great presentation. It looks like we had one question. It was early on, about 10, 15 minutes into the presentation. Is it following the same pattern of WDM data transfer? I'm not really sure what part of the presentation that was on. Maybe you might have a sense.
I don't know, because I've never heard of DWM data transfer. So I am trying to quickly Google it so I could give a answer. Otherwise, I can answer offline as soon as I'm able to figure that out. Wavelength. Oh no. So WDM. Yeah, no. WDM is it's your protocol at an optical layer. So how you send light over fiber optics in order to get the most utilization of your fiber optic band. OpenZT is working at a layer 3 to 5 in the TCP/IP stack rather than layer 1 of WDM. So effectively, IP based TCP UDP, being able to send traffic from somewhere to somewhere. The layer 1, yes, it may be using WDM, it may be Ethernet, it may be whatever. In fact, is Ethernet even layer 1? That might be layer 2. Anyway, there's stuff happening at a photon level lower in the stack, but OpenZT is operating as a mesh overlay, a private mesh overlay on top of the internet. Yes, I can share with you. So in fact, even just today, I was talking to someone about Node.js, and I shared. Let's see. I will. I will find some. In fact, Manish, even better is going to be asking in Discourse, because in Discourse you won't be talking to me. You'll be talking to one of our developers who will be able to give you a much better answer than I can in terms of examples for Node.js. I know within our, and so here's the link to the repository for the Node SDK. There are some examples which are in there in terms of building applications. I'm highly confident, though, there is also some documentation, potentially a video as well, in terms of embedding our Node SDK into an application, but I don't have that off the top of my head. But you can definitely very easily get that information by asking within our Discourse community.
And then Philip, so if anybody had additional questions about the technology, as would they go to the OpenZD discourse group? Is that where you're suggesting they go to ask any additional questions?
Yes, you could do that. Also, so that didn't format very well. Sorry. I will also grab my email address and I will put that in the chat window. You are more than welcome to shoot me an email to ask any questions, and I will happily give you some responses or link you into someone who can answer it much better than I can.
Terrific. And then, so that actually flows into my last minute housekeeping items. So Philip is given out his email address. You can check on the screen for that contact information, as well as you've already received some additional emails about being as you are a hack participant. Those people who are attending this webinar, details about the different hack challenges, details about participating in the event, and then the judging, and when that's all taking place. But if you have any additional questions kind of generally about the overall hackathon, you contact Dev Network directly, and that will be on the information you received from us at Dev Network. But anything specific to this challenge, to NetFoundry's challenge, you would either access, or you can contact Philip at the email address that he supplied, or at the openzd.discord.group location for additional information there as well. So last housekeeping item, as I noted before at the beginning, there is a recording of the session that will be available in about 12 hours. It will be emailed out to everybody who is participating. So if you have any additional kind of want to review or maybe share that with your hack teammates, they can take a look at it. Before I close out, Philip, did you want to say anything, any last words?
The only other thing I would mention too is we have a couple of talks at Developer Week. One is our CTO on the main stage talking about OpenZT. And then the second one is Clint in our advanced development team, who is specifically talking about the Prometheus topic and Zetifying Prometheus. In addition, as you're working with OpenZT in the hackathon, we love GitHub stars and following our Twitter channels and stuff like that. Ziggy is a very opinionated piece of pasta, so feel free to follow him and have some fun.
All right, terrific. Well, we look forward to everybody participating. Philip, thank you very much, and thank you to NetFoundry as being one of our sponsors for the event. And we look forward to a great event. And again, if you have any questions, shoot Philip an email. But other than that, everybody have a great day. Bye.
Thanks,
now.
everyone. Bye.